Hello Algebra students, today we're doing 9-5, completing the square. Your learning targets are to solve a quadratic trinomial by completing the square to transform a quadratic equation into a perfect square trinomial. Use completing the square to write a quadratic equation in vertex form. Our vocabulary today is binomial factor, factor binomio, perfect square trinomial, trinomio cuadrado perfecto, vertex form, forma vertici, completing the square, completar el cuadrado. I think there's a typo here. That's from the book, not me. Example 1. What value of c makes x squared plus 6x plus c a perfect square trinomial? So I'm actually going to change that to yellow highlighter. We'll see why in a minute. So what they're asking us to do is basically take this picture and make it into a perfect square. So we're going to redraw the blue square like this. And then you're going to draw 3 of the bars this way, and then 3 green bars going this way. And when we do that, it's almost a square, but we're missing this piece of it, which if we separate, like so, we end up with 9 yellow squares in there. And so the answer to this question, if this is x squared and the green ones are x's, then we're left with 9 little yellow squares. So c would be equal to 9, and you would plug that into the equation, so you would have x squared plus 6x plus 9. And then there is a theorem for this that says that what we do is we have x plus b over 2, and so x squared plus bx plus b over 2 squared is equal to x plus b over 2 squared. So the b over 2 is important. In this case, 12 is our b. B over 2 is equal, I'm saying and writing at the same time, b over 2 is equal to 12 over 2. 12 over 2 is equal to 6. And then if we square that, we get 36. And that would be our c. All right, so we're going to take 8. We're going to divide it by 2. That equals 4. We're going to square that. That equals 16. So 16 is our c. And those are our answers to that question. All right, you're ready? Turn your page. Example 2. How can you find the solutions of x squared minus 14x plus 16 equals 0? The first step says write the equation in the form ax squared plus bx plus d, or equals d. So what that means is we're going to just write x squared minus 14x, but instead of plus 16, we're going to bring the 16 over to the other side as negative 16. The next step is we're going to complete the square. We're going to add b over 2 squared to both sides. So negative 14 is our b. We're going to divide it by 2, and we're going to square it. So that would become negative 7 squared. Negative 7 times negative 7 is positive 49. So we're going to add 49 to both sides, and that's going to end up looking like this. X squared minus 14x. We're going to add 49, and that's going to equal negative 16 plus 49. And the step 3 says we're going to write the trinomial as a binomial squared. But first, we got to simplify this down a little bit. Negative 16 plus 49. I'm going to end up subtracting that, and I'm going to get 33. So x squared minus 14x plus 49 equals 33. Now I can write it as a binomial squared because 49 can split into 7 and 7. If we make them both negative, then that will give us, when we add them, negative 14. So we're going to write it as x minus 7 squared, because it's twice, right? Because we had 2 negative 7s. So that's why we're going to square it. And it's going to equal the 33. Now we just need to solve for x. So we would have x minus 7 squared equals 33. I'm going to take the square root of both sides. And when I do that, I get x minus 7, because the squared and the square root cancel, equals the square root of 33. The next thing I need to do is add 7 to both sides, and that becomes x equals the square root of 33 plus 7. So my solutions are the square root of 33 plus 7 and the negative square root of 33 plus 7.